All right, so before we start into these proofs, I want to give you some items on the notes page. Couple of what might be kind of new things, and then maybe summarize. What's that? Yeah. Okay. So, terms we need to know. We talked about a segment bisector not long ago, right? It's something that divides a segment into two congruent segments. And what point did that bisector go through on the segment that it bisected? It went through that segment's what? What is it? Midpoint, right? Well, what's a midpoint? Kind of. Right. Well, midpoint is the point that divides the segment into two congruent segments, right? It divides like a bisector, right? But it's just a point. Divides a segment into two congruent segments. So for example, if one of the proofs we do is prove these triangles congruent, and they tell you, well, one part of these triangles is the midpoint of this side, right? So when you need some segments congruent, say like side angle side, well, you can use midpoint to say a couple segments are congruent, for example. So if I have a situation like this, I'll draw a segment, AB. Should look a little familiar. Here's M for my midpoint. Those two segments are congruent. And I can say they're congruent, and I can justify them for this statement. Can I say that AM here is congruent to BM? Definitely, because that's a midpoint that I've just defined, right? Just defined midpoint. So I could justify making a statement like this by what? The definition. No. Of midpoint. Which is something you'll use in your proofs, okay? I just defined midpoint for you, and if you want to be able to say that those two segments are congruent, you could justify saying that by saying definition of midpoint. Okay. So now we know about segment bisectors and midpoints. You split a segment into two congruent segments, right? So let's talk then about angle bisectors. What might that do? No idea? Well, it would divide an angle into what?
Two angles.
To what?
Corresponding sides.
Nope.
Two corresponding angles.
Well, if it bisects it, what does the segment bisector do? It divides the segment into two what? Congruent segments. So an angle bisector divides an angle into two congruent angles. There we go. So it divides an angle into two congruent angles. All right, and I'll draw a picture. So here's an angle. I'll call this point there. We'll call that A. We'll call that B. C. And I'll draw this here. And I'll call that point D. And now let's say that this ray BD bisects this angle. What did I just mark there? That those two angles there are what? They're congruent angle marks, right? So I can now say that angle what is congruent to angle what?
Angle B is congruent to
A's not it.
angle.
Wait, stop right there. What are you talking about? When you say angle B, which angle are you talking about? This one, or the whole thing?
Angle 1 is
Well, I don't have numbers in there. I want to use letters.
Angle B, angle B.
Angle B, I'm going to angle, which of the angle B's? There's three possibilities there. What do we have to use if there's a question? How many letters? Three. In our angle name. So what's this top angle? Angle what? ABD. Angle ABD is congruent to angle what? CBD. You guys all understand why you have to use three letters there, don't you?
Oh, yeah, it's four.
Well, I can't just say angle B because no one knows what you're talking about, right? You got to specify. Sometimes you can just say the single letter because there's nothing else it could be, right? Okay? So don't make that mistake anymore. And what would be the reason? I could say they're congruent by what? Definition of, because I just defined it for you, right? Definition of angle bisector. Okay? So we have a couple of possible reasons for proofs. I'm going to jot down a couple more. All right? So let's take a look. Let me just draw a little line here. I'll just call this possible proof reasons. Reasons to say things are congruent and whatnot. Would be a good idea to compile some of these, not an exhaustive list, and we'll learn some more as we go along, okay? Well, we already covered definition of segment bisector, didn't we? Like if you need to be able to say that two segments are congruent to each other, right? Definition of segment bisector. Crazy. And what's kind of similar to that along those lines? Maybe they didn't tell you that segments bisect each other, but maybe they told you what? That there's a midpoint, right? Midpoint would be the same thing there, right? Definition of midpoint. Okay? What might allow me to say, if I need to, or justify saying that two angles are congruent to each other? Definition of angle bisector, right? Definition of angle bisector. All right. What's another way that we learned it that makes two angles congruent? Yeah, we got reflexive property. Vertical angles are congruent, aren't they? Right? Vertical angles congruent. So maybe you got a diagram, right, where you have vertical angles, what they said congruent. Well, okay, angle whatever, congruent angle whatever reason. Vertical angles are congruent. And then we also have reflexive property, like if two triangles share a side or two triangles share an angle together, right? We've got the reflexive property. All right. And then actually to prove that two triangles are congruent, what do we have? Yeah, all that stuff.
And we have CMCT.
Ah, what is it? Corresponding parts of congruent triangles are congruent. What is it? CP. Corresponding parts of congruent triangles are congruent. CTC. So we need to keep these reasons kind of floating around our head because we're going to add more to them. And you're probably wondering, well, what the heck is this going to look like, right? With these proofs and whatnot. So we're going to flip back so everybody copies that. What's what? Hypotenuse slave. That is right. Correct. All right, we got that. Let's flip back Let's flip back and look at some real simple little examples of proofs. So these will take up like 3 lines, okay? So when you get a proof you're asked to prove something. There are 3 things that they give you. 2 definitely. They give you a statement here to begin with. It's called the given, okay? Everybody see this given in this case? And then they give you a diagram, all right? And this given applies to that diagram. And then they give you a statement here of the thing they want you to prove, okay? So in this case, here's our diagram, all right? And then they tell us that angle BDT is congruent to angle GTD. Now, if it's not already marked, sometimes what they give you will be marked in the diagram. In this case, it's not. So what should you do?
Mark it.
Well, mark it, right? So let's mark angle BDT. So for BDT, this angle here is congruent to angle GTD. Congruent to that angle. They're marked. Now, they also give us what? BD is congruent to GT. Let's mark those 2 congruent. That's our given. What do they want us to prove? Prove the triangles are congruent. Do we have ways to prove, if there's to prove triangles congruent?
Yes.
What are they? Side, all that stuff, right? So we're going after one of these things, okay? Well, let's look at what they gave us in this case. So before we start writing the proof, you start making this plan, right? Had they given enough information in the given from just what's here to say those triangles are congruent by one of those methods? I have a pair of sides and a pair of angles. I've got an S and an A.
But
All right, so so we don't have enough from what's given, right? But we have a few ways to find other things in here that we can use, right? Based on the homework we did. Is there anything else in this diagram that we can find congruent that will allow us to prove the triangle is congruent by one of those? Okay, what is congruent to what by the reflexive property? Right, they share TD, so it's congruent to itself by the reflexive property. Okay. Now, is there enough information to prove the triangle's congruent?
Yes.
Which one of those? Side, angle, side. Oh, that's our plan to make the proof now. Okay. So now we start writing the proof. Now, you'll make statements over here. Everybody pay attention. All your statements will be numbered. And statement 1 will have reason 1. Statement 2 will have reason 2. I want numbers that correspond to each statement and reason, okay? Now, the first statement in a proof, always, every time, is what they give you. It's this stuff, right? So you basically have to copy that down. Or you can abbreviate it, shorten it if you like, but it all has to be there, all right? Now, statement number 1 is the given. What justifies us being allowed to make that statement? That it's given, simple as that, okay? All right? So, now we start writing down things that we found. What was it that we found? We didn't find reflexive property. We found TD congruent to TD. So that's our statement. Statement 2, right? Now, what justifies being able to make this statement? Reason 2. Reflexive property. See how the proof goes, right? You make a statement. First make a plan, then you make a statement, and every statement has a reason. Now, have we stated enough things to say the triangles are congruent by side, angle, side?
Yes.
We have to check this, right? And you're going to have to, everybody do exactly what I'm going to do. So for a pair of sides, that S, we need a pair of sides stated congruent. Do we have that? There's an S. Do we have a pair of angles for A stated congruent?
Yes.
Right there. There's another S. That's another pair of sides. Do we have that?
Yes.
Stated here, right? All 3 pairs are stated. A pair of sides, a pair of angles, and a pair of sides. Everybody got me? All right? So all of those, there's my 2 pairs of sides and my pairs of angles stated. So now I can say triangle, exactly what, right, you always write exactly what they have there. BTD, congruent to GTD, reason that justifies that, side angle side. You get the idea? And these are simple, that's a 3-step proof, right?
What's the one that says that?
Oh God.
We go to.
When I was in college doing stuff in, upper level college math classes, we'd have proofs that went on for pages and pages. There's some proofs that have lingered for 2,000 years or more that no one's been able to prove. Like Fermat's last theorem, until after like 2,000 or 2,500 years of no one being able to prove Fermat's last theorem, some kid over, I think it was Israel or Saudi Arabia, kid was like 14. After all the great mathematicians that came before him, and he proved it. It was several pages long. He did it anyway. But you got 3 steps here, maybe 4 now. All right, let's look at the next example. Here's the diagram. Everybody see it? Now, what do they give us? Angle B congruent to angle D. What are we going to do with that? Mark it. Mark those 2 angles congruent. What else do they give us? And C congruent to EC. Mark it. Okay? And what do they want us to prove? Triangle BCA. Triangle. Okay, we're going to use one of these methods as what they've given us allowed us enough information to use one of those methods. No, we need something else. We can find vertical angles. So what 2 angles are congruent?
C, D.
Always put the vertex in the middle of your name. Vertex goes in the middle. CED would be this angle up here if you called it CED. Vertex goes in the middle.
Oh, I see what you're saying. So it'd be BCA and then
Angle BCA, and I'm going to use a double mark here, congruent to,
ECP.
okay, ECD.
Can we use numbers?
Later on. Later on. We'll get to the shortcut number thing soon enough. Okay? Now, because vertical angles are congruent, right? Do we now have enough to prove the 2 triangles congruent?
Yes.
Which one?
Angle, size.
Angle, side. Okay, so now we've got our plan, right? Now we can start writing the proof. Okay? Get your plan first, okay? So statement 1 is always the what? And it's justified with the word given, reason 1. Then you start writing things that you found. We found that angle BCA is congruent to angle DCA. Why? Now, when you write this down, here, listen carefully. When you put this reason down, you can't just write vertical angles. You get no credit whatsoever for that.
Which is the angle, vertical angles.
Vertical angles are congruent. See that? You can't just write vertical angles. You can, but you get no credit, okay? What about, find their vertical angles. What about them? We're trying to say they're congruent. So we write vertical angles, we know we're congruent. Everybody, vertical angles congruent. Now, that should give us enough to say the triangles are congruent, but let's check. Angle, side. For that first A, do we have a pair of angles stated congruent? Yes. For the other A, is there another pair of angles stated congruent? They're stated, okay, in our statements and reasons. It can be in the given. Not just marked in the diagram. They got to be stated. For this S, do we have a pair of sides stated congruent? AC and EC. So now we can say that triangle BCA is congruent to triangle BCE by angle, side. How many kind of get the gist of this, how it goes? First thing you do is mark the given that they give you in the diagram. Second thing you do is start finding things that are congruent that you might need to prove, right? Okay, that's all right, well. So what we're going to do then is let you guys try number 1. Okay? This one you're going to do on your own. Now don't do this. I see kids do this. They just start doing 1, 2, 3, right? Don't do that. You don't have no idea how many lines each one will take. I don't know if you learn that in 4th grade or something, like for a spelling test best of vocabulary.
Yeah.
No, this ain't that, okay?
Or how we would do
No,
lines.
well, we're not doing that, okay?
with the line.
You don't know how much, you might need like 2 lines for your given, okay? Yeah, just don't even start until you make a plan, okay? All right, so everybody right now, look it over, mark your diagram with the given, and make a plan for this. So they gave us an AB congruent to AD, and that BC is congruent to DC. And that is not enough for any of those, right? Side, angle, side, any of them. So we need another pair of somethings. Now, what did you say that we can also find congruent in this diagram? Okay, we can't find the reflexive property congruent. That'll justify something. They share AC, don't they? So I'll use a triple mark there. It's congruent to itself. Does that now give us enough to say the triangles are congruent by? Okay. So let's start writing our proof. The first statement is always the what? All right, so they gave us that AB is congruent to AD and BC to DC. BC congruent to DC. What's the reason for this statement? Given. Okay? And our next statement will be statements about things that we found. What did we find? AC is congruent to AC. Now we have to justify that statement. Why is AC congruent to itself? Reflexive property. Reflexive property says everything is congruent to itself. Well, AC is itself. Well, can we now say the triangles are congruent? By? Let's take a look, double check. S, the 3 S's, right? Do we have a pair of sides congruent for one of the S? For another S, do we have another pair of sides stated congruent? And for the third S, do we have another pair of sides stated congruent? We've got them stated, not just marked in the diagram, right? So now we can say this. Triangle ABC is congruent to triangle ABC. Reason is SSS. Okay. Going a little bit better? All right, move on to the second one then. Ooh, we got a midpoint in there. Might be able to get a statement of things congruent with a certain reason they gave you in your old page, didn't you? All right. I'm going to go ahead and mark the diagram with stuff then. We got angle B, congruent, just different colors so it stands out, I guess. Angle B is congruent to angle D, and C is the midpoint of AE. We can't really mark that as it's right, but what does that mean? The C is the midpoint of AE.
That A would equal C.
Yeah, A is a point.
AC would be equal to EC.
Yeah. So we'll mark that, even though they didn't tell us their so we'll need an actual statement about what's being congruent, right? Okay. I'll give you a minute to formulate this. I'll go ahead and put the given out there. So you know that's going to happen. 1, angle B is congruent to angle D, and C is midpoint of AE. You guys see how I can, I got all my give, I can abbreviate it, you know, but I have it all there. Yeah,
It's 24 long.
might be. Yeah.
Oh, wow.
Sometimes that happens, I guess. Just fix that. Statement 1, reason 1.
BCA.
Okay, so we can also, okay, why are these congruent? I'll use a double mark on these angles. Why are they congruent? Because, You're gonna write as a reason exactly what?
Vertical angle congruent.
Vertical angles congruent, right?
Oh,
Yeah, well, what'd you add?
I said vertical congruent. Okay, so-
Oh, no, vertical angles congruent, yeah. Will that give us enough to get the triangles congruent?
Yes.
By which one?
Yes.
Angle, side. So what's the proof look like? What's our second statement? AC congruent to EC. Reason we can make this statement? Yeah, definition of midpoint. Feel free to abbreviate, right? Because, you know, as long as it's abbreviation that's clear, we know what you mean, it's fine, okay? Did that still give us enough to get the triangles congruent?
Yes.
Or did it yet?
No.
No, we need the other thing, right? What's the other thing we found up here?
No, angle.
Not triangle.
DCE. Congruent to-
You meant to say angle, right? Angle, we need 3 letters, don't we? What is it?
DCE
DCE,
is congruent to BCA.
congruent to angle BCA. Reason?
Vertical angle congruent.
Vert angles congruent, not just vertical angles congruent. Okay? Can we now say the triangles are congruent? By what?
Angle on the side.
So let's double check. We're going to use angle, side. That's an A, and an S. Do we have a pair of angles stated for one of the A's?
Yes.
B and D. Do we have another pair of angles stated for the other A?
Yes.
And the S, do we have a pair of sides stated congruent? They're all stated, okay? And by the way, in your proofs, you won't have to underline those. Just doing that so we see explicitly, right? Okay, so now we can say that exactly how they have it. Triangle. So for triangle BCA is congruent to triangle DCE. DCE. Angle, side. Can you hang of this thing? Okay. Over. Huh? Yeah, let's go take a look at these guys here. You know, whatever they give you, you know, label it, throw the diagram. Okay, it'll help you answer things. Read the first one. It's about young lady and Kelly completing a proof. Nice. I'm going to definitely go ahead and mark, and you should too if you haven't done it already. Stuff that they gave you here, mark it in the diagram. So we'll do angle A, congruent to EDS. See why they have to use 3 letters? Right? That way you know it's this angle here. EDF. Vertex in the middle of the name. And she proved that AB is congruent to DE. So AB to DE.
I think it is number 2.
Number 2. So what's the key word here is what?
Not
Not prove. And by very specific ways for each one, right? Like one of them might prove the triangle's congruent like here, but not by side angle side. See what I mean? So you said number what?
2.
So what do you guys think? Huh? Any other thoughts? It's a good idea to go like instead of sitting, go on the diagram and just lightly mark in what they give you there and see if that works, right? And then if that doesn't answer, erase it and go mark the next thing in there. So I'll do that. Let's say AC to DF. So if we do that, to that, would that get them congruent, not congruent with side angle side? Well, that is side angle side, right?
Okay.
So it violates the not part, okay? So that is definitely side angle side, okay? It's 4, you say? Well, let's go to 4. Angle CBA. CBA congruent to angle FED. And it'll be angle side angle. It looks like angle side angle, doesn't it? Angle side angle. So that again violates the word not, okay? All right, so that is definitely by angle, that was angle side angle, all right? What else do you think? See how I'm checking them and then erasing and checking them?
I know it's 2.
She knows this too. BC congruent to EF. EF. Okay? By side, will that get them congruent by side angle side? It will. Side and include an angle.
No. It would have to be DF.
That is angle what?
Angle side side.
That's angle side side, not side angle side. And in either case, it won't prove congruent whether it's that or not, right? So that's our not part. Okay? Let's move along. And again, I would definitely make a sketch of these two triangles and mark what they tell you in there. A, B, C, and D, E, F. Really doesn't matter how you make them. That's super important. And then they're telling us that angle B is congruent to angle E. So that'll be the case no matter which choice we're looking at. So we'll mark those angles congruent. Remember, you could start marking each of these choices lightly with pencil and diagrams. See if it fits or doesn't fit. Before you want to take a stab at it. Let's see, he says choice 2. AC, remember, mapping onto means equivalent congruent when it's isometric, right? So AC, let's mark those. AC congruent to DF and BC, huh?
That was wrong. I was looking at 1.
Okay, let's just see. Oh, God, well, what is that?
Let's take it.
Oh, my goodness, we can't have that. I'm not sure why.
3.
All right, she says 3. Let me just do something. Let's check choice 3. C maps onto F. And the other thing is BC congruent to EF. Okay, that looks like what?
Angle or
What is it?
angle
No,
angle side.
that's angle side and angle, right? Okay, that works, right? But wait a minute, what's wrong with, why wouldn't 4 work? A to D and AB onto DE. Wouldn't that, oh, what now?
This is point A.
This is part of the diabolicalness of these written exam writers. I don't really like them. It says point A onto point D. But when we're talking about mapping figures onto figures and the parts, the corresponding parts mapping, what are the parts we're talking about? Angles and sides, not points, right? Not points, okay? So that one, if it had said angle A and angle D, would have been a correct choice. But it did, it said point. Everybody get that silly little distinction there? Okay, that's one of the ways they always try and catch you. Okay, let's move on to number 3. This should start looking familiar. We've answered a couple like this already.
Corresponding sides.
Yeah, so
That's Y, A, B, C. B, C, S, S.
Why are they congruent? You just told me that all the corresponding sides map to one another, so the triangles are therefore congruent by what? There, we can tack that on, is that right? You specifically mentioned all the corresponding sides, right? Okay, so first of all, did you say that reflections are,
They're in motion.
yep, so reflections are rigid, something like this, or isometric, doesn't matter. So all corresponding sides, not just all sides, right? You'll miss points for that. Corresponding sides congruent, right? So we can say that triangle ABC congruent to triangle A prime, B prime, C prime, triangle A prime, B prime, C prime, by what? Side, side, side. Okay? All right. So we delved into proofs a little bit. We've got 2 days on this. And I'll give you your problem set here. So for the problem set, day 1, all of them. Day 2, all of them. I know, but this is one moment where we really need to practice, okay? So